we're doing 1.2 square roots. And this will be, again, kind of like what I was saying before. It'll be a little bit of me trying to figure out what you already know. And then anything that you don't know, I'll teach you the new stuff. But maybe it's going to feel like a lot of review. So just to start off with, we call a number like 144 a perfect square. Does anybody know why it's called a perfect square? Yeah. The two numbers that multiply to give us that they're the same thing, right? So what times itself gives me 144? Yes, 12. Everybody good with that? So basically a perfect square is a number that can be divided by another number and it would give me that same number as the answer. Does that make sense? So if I took 144 and divided by 12, I would get 12. Good? Can you tell me some other perfect squares? You can just call them out. You don't have to put your hand up, but just call out some other perfect squares that we know. 9's one example. Anything else? Sorry? Okay, 1221. How about the smaller? Let's start with the smallest. What is the smallest perfect square that there is? This could be a little bit controversial, but yes. 1. What's the next one? So 1 squared gives us 1. What's 2 squared? 4. And then what's 3 squared? 9 and 4 squared? 16. 5 squared? 25. So the 16, 25, 9, all those numbers are examples of perfect squares. Are we pretty good with perfect squares up to, let's say, 10 squared? Do we know 9 squared? What's 9 squared? 81. 8 squared? 64. So you kind of know these, and that's the kind of stuff we're going to be working with today. Okay, so then let's make it a little bit more complex or a little bit more stuff going on. Actually, no, we'll come back to that. We just talked about it. What's the square root of 1? It's just 1. What is the square root of, if we have something like 81x squared? So there's a lot going on under that root sign. Actually, before we get to it, does everybody know what we call that symbol? If we have that symbol and we have a square root, do you know what the name is? It starts with a R. It's called a radical. So if you ever hear that term, I mean, really, you don't need to know that. I'm never going to ask you that. But if you ever hear that used, this is what we're talking about. We're talking about square roots. So we can split this up. What is the square root of the number 81? It's the opposite of what we just talked about. The square root of that is 9. Good. And then we can split it up to look at what is the square root of x squared. That I don't know if you've done before. Have you? What times itself gives me x squared? So what is the square root of x squared? X. So the square root of 81x squared would just be 9x. So it's kind of like you can treat them separately, but then we put it together in the end. Questions about that? Is this review for some of you? Some people it is, and some people it's new. No problem. Good? And then what about the square root of -9? How about, is there anybody who hasn't answered yet? Again, I'm not going to call you out by name, but I want to give everybody a chance if they want to, and if you don't, that's all right. Okay, what's the square root of -9? It's an imaginary number. Basically, we can't do this. We would say it's undefined, and that just means you can't, because if you took a negative number, well, if you just look at the 9, what number comes to mind? What are you thinking of? 3, right? But there's a negative in front. So if we did -3 times -3, what's the answer to that? What happens when you have a negative times a negative? It's a positive. So the answer to that would be 9. So there's no way we could take some number, multiply it by itself, and get a negative answer. So we can't have negatives under the root sign. Whenever that's the case, we would say it's undefined or we can't do that. Questions about that at all? And I encourage you to ask questions if anything's unclear or you're not quite sure. How about the square root of 0? Undefined also? Well, 0's, again, controversial or a little bit weird. 0 and 1 sometimes have their own set of rules. The square root of 0, technically, you could say it's equal to 0. Yeah, it probably won't come up very often, but I figured we would go through it. And then, if we have something like this, basically we have a fraction under the radical or under the root sign. But what I wanted to show you is we can treat this kind of like the 81x squared. So they are together, and you don't actually have to write this down when you're doing your work, but I wanted to show you it's kind of the same thing as saying this. So I could separate it and put root 16 over root 121, and then I could ask you if we just, so much of what we do in here, I'm going to teach you to basically live in denial, hide half of it. If we just had that root 16, what is the square root of 16? What would be the answer? Yeah, this would be 4. Everybody good with that? And then we bring back the part we were hiding and pretending it doesn't exist. You bring it back when you're ready to see it. What is the square root of 121? Yeah, 11. So the answer, after going through this, would be the fraction 4 over 11. So it's kind of like you're treating them separately, but you do put it together at the end. Okay so far? Okay. Ooh, so here's where things start to get, well, not super tricky, but, you know, there's a bit more going on. So when we have something like the square root of 100 plus 25, and those are both under the root sign. I just wanted to show you, because sometimes people want to do root 100 plus root 25. We cannot do that. So if they're under the root sign together, we first have to add those and then look to see if we can take the square root of that. So what is 100 plus 25? You all know this. It's just root 125. And is that a perfect square? Like, is there a number times itself that gives me 125? No, right? So this is going to be our answer. There's nothing else we can do with that. Eventually, we'll learn something else we can do with this when it's not a perfect square. But for now, it's only the second day of real, like, learning new stuff. So we won't do that quite yet. But we will eventually. Questions before we move on? It's good so far? Okay. Without going through the process, just by looking at this, do you have an idea in your mind of what you think the square root of 0.25 might be? What do you think it might be? Yeah. 0.5. Does everyone agree? Sometimes with these questions, it's hard to figure out, is it 0.5? Is it 0.05? So the answer is 0.5, but I want to show you a strategy of how to come up with this, because they're not all going to look like this, and then we'll practice that later on. If I were to change this 0.25 into a fraction, like we did a few days ago, what would this be as a fraction? Yes. 25 over 100. Is everyone good with that? We reviewed it a few days ago. Because I moved this over twice, I know I'm putting 2 zeros there. So it's 25 over 100. And now this is just like the one we did before with the fractions, top and bottom. Square root of that, 5. Square root of 100, 10. And then 5 over 10. That's how we got our answer. Good? I didn't even ask you. On the scale of 1 to 10, like 10, you're in genius mode, ready to go, energized, and 0, you're barely here, not quite awake. Where would you say you're at today? I would say I'm like maybe here. Okay, so given that, I feel like things are looking up. We're getting better day by day. Is this pace okay? Okay. Okay, so here's an example of the reason why I showed you that strategy on the last one. Because with this one, just by looking at it, do you have an idea of what you think the answer might be? Because you know how the last one was 0.25? If this was 0.36, I think you would know. But it's 0.0036. So I find sometimes people mix up the number of decimal places or what they think it might be. Yes. Oh, sorry. Is your hand up? No. Yeah. Is that George? Oh, Leo. Oh, sorry. I thought George's hand was up. Yeah, Leo? 0.06. Does everyone agree? Or kind of unsure, but you think that could be a possible answer? Okay, let's figure it out. Let's see if that could be our possible answer. If I wanted to rewrite this as a fraction, I know I'm going to have 36 at the top, which is a perfect square, but what would I put at the bottom? How many zeros? 1, 2, 3, 4. So do you see that always tells me like the number of times I move over the decimal is the number of zeros I put there? So 1, 2, 3, 4. Good? Now what's the square root of 36? 6. Well, first of all, what is this number at the bottom here? Not 1,000, but you can call it out. 10,000. And what is the square root of 10,000? Well, when we take square roots of something with a whole bunch of zeros, you basically just chop the zeros in half. So you know how we have 4 zeros here? So what would be the square root of it? 100. And what is 6 over 100? Well, we would take this decimal and move it over twice. So yeah, this would be correct. Good? Yes? Yeah. Okay, good question. What if there's 5 zeros? So then is it a perfect square? If we had 1,000, for example, if we had the number 1,000, is that a perfect square? Is there something times itself that can give us 1,000? No, so that's a really good question. So it's that little rule or method of chopping the zeros in half will only work if we have an even number of zeros. Okay? I feel like I'm missing stuff. Nope, I guess that's it. Area of a square is 144 meters squared. What must be the length of each side? Well, for starters, my drawing skills aren't the greatest, but that's as good as I can do. If we have a square, well, first of all, have you learned how to calculate area last year? Maybe we need a refresher with that. Well, if we don't know the length of something, what do we normally call it? Like we usually use a variable. What variable could if I don't know the length of this side, what could I put there? Maybe an x? Have you worked with variables? Yeah. So if you see all the sides on a square are the same, so if I wanted to calculate the area, what would it be? Forget numbers, but using these variables, what would it be? X times x, which gives us what? X squared. Does everybody see how I'm coming up with that? So to get the area of something, it's always length times width, or the width times the height, however you want to refer to them. But so I would take this x and multiply it by this x, and that's how I get the x squared there. Now we were told that the area of the square is 144 meters squared. Where do I plug that into this little equation? In for which variable? Yeah. If the area of the square is 144 meters squared, right? X is representing one little side. So the area, this would be our A value. So in here, I'm going to plug in 144 meters squared equals x squared. I'm going to say temporarily, let's get rid of that unit. I'm just going to use the numbers, and we can talk about that after. But 144 equals x squared. Everyone good with that so far? Want to ask me anything if it doesn't quite make sense? Good? So then, I don't know if you've ever heard this before, but you're going to hear me using it a lot. Algebra is all about opposites. So if I have x squared, I want to get just x. I have to do the opposite of squaring something. What's the opposite of squaring something? That would be the opposite of multiplication, right? And the opposite of adding would be subtracting. What is the opposite of squaring something? The stuff that we're learning today. So I would want to take the square root of this, which means I also have to do the same thing to the other side, because an equation is like a scale. We have to keep things balanced. So when I do that, well, if I have, imagine I multiplied something by 5, then I divided it by 5, what would end up happening? Everything would just cancel, right? Because they're total opposites of one another. So do you see a square root and squared are opposites of each other? So I'm left with just an x there, which is the reason we did that, right? And what is the square root of 144? It's 12. So we just found that x is equal to 12. If the area was meters squared, what do you think that the length of one side is? Which unit? Just meters. So I could say the length, we always want to write it in a sentence after. The length of each side, oh gosh, writing on here is tough. The length of each side is 12 meters. And that would be our answer.
That was easy.
Good? Okay, so I'm going to give you this to work on.